Can you tell me what is the collision theory that we have discussed in the last class? Like, what does this collision theory explain to me?
What theory?
What?
Which theory?
I'm not able to hear you properly. Can you speak louder?
Which theory?
Collision theory. Collision theory. This is the theory,
Oh,
collision theory that we have discussed now. Ki, like we are having A as a reactant, B as a reactant, and we are taking as it in a spherical shape as the postulate. This is the postulate that we have proposed, that the reactants would be in the particles of the reactant would be in a spherical shape, so that the collision will occur between them, and there is an energy gap, which basically there, if the collision is able to break that energy barrier, then the product formation will take place. So this is about the collision theory. So
yeah.
basically, I'm going to quickly revise you the collision theory. So basically, collision theory is nothing but it explains you that how product product formation takes place. How products formation takes place. This is the collision theory. So if you see the collision theory is basically based on what? It based on the product formation, the process of the product formation. So
Yeah.
basically we are having so it tells us about that we are having, let's say, two reactant molecules. This is the two reactant molecules, and we are considering them in a spherical shape. We are considering them in a spherical shape. So these are the two particles. We are considering them in a spherical shape. This is the postulate that we are, stating. And then after, there is an energy gap, energy barrier is there. If this collision is able to, the collision through which the energy which is produced, energy that is produced is greater than the energy barrier, then the product formation will takes place. So now in this theory, we are going to discuss about the terms which is associated with this collision. So the first term would be the collision frequency. So collision frequency is nothing but it's the number of collisions that is happening, that is taking place in a per unit volume of the area. Like this is the unit volume. In that unit volume, the number of collisions taking place taking place is my collision frequency. Is my what? Is my collision
Col-
frequency. Now, what is
Collision frequency.
effective collision? So the effective collisions are those collisions which are responsible for the product formation, which are responsible for the product
Yeah.
formation. Like there are many types of collisions that are happening, but all the collisions are not going to be resulting in the product formation. So only those collisions that are going to be form the product are the effective collisions. So basically, it is those collisions which are capable to bring out a chemical change to
Forming the
form a
product.
product. It is known as the effective collision. Okay. Now, basically how this will happens when the barrier will going to be going to be cleared, or I can say that the barrier, if it overcomes the barrier, if the collision
Yeah.
basically collision effective collision energy barrier is going to be more than that of the energy barrier. Okay, so energy barrier I have explained you. Now this is the
Yes.
graph that is the most important graph that we have discussed in the last class. Now I'll again explain you the how this graph is. So basically, this is the energy in my y-axis, and here it is my progress of reaction. Progress of reaction. What is happening here is that there is two levels, the first level and this is the next level. So this level is basically of my reactant, and this level is my for the product. It depends what type of reaction it is. If it is a endothermic reaction, this will be the graph, and it will be the, if it will be the exothermic, then the graph would be different. But the concept would be the same for any graph. Okay, so this is the energy of my reactant,
Okay.
and this is the energy of my product. And if I want to form a product, then there is a gap between the reactant and the product. If you see that, if my reactant is able to cross this level, if my reactant is able to cross this level, then the product formation will take place. So this level is basically the energy formation in for and activation energy in the forward reaction. And this is the gap. If the reaction is reversible reaction, then this is the gap for the product to form the reactant, or I can say that for the P to form a R, it is the activation energy for the backward reaction. So there are two terms, two energies. The one is the activation energy for the forward reaction, and the other one would be the activation energy for the backward reaction. And their subtraction, their difference, the activation energy difference in the forward direction to the activation energy to the backward reaction, that would be equals to the delta H of the reaction. It is delta H, basically the energy of a reaction. If it comes out to be positive, if it comes out to be positive, that means that it is an endothermic reaction. And if it comes out to be negative, then it would be exothermic reaction. Understood? Understood? Now, these are some other factors that we have
Yeah.
discussed. What is activation energy, the extra energy that is required for the reactant to convert into the product, and there is the orientation barrier, the factors that affect the collision. So there is the most important factor, that would be the orientation factor. If the collision is a head-on, then this would be called as the proper collision, and in which the product formation will be taking place. Now let's move on to the factors. That the first factor would
Yes.
be my surface area. More will be the surface area, more will be the rate of a reaction. Okay, if the surface area is more, then the chances of
Directly
the
proof.
would be the more. So that's why it is directly proportional. Now the next would be my physical state. If it is a gas, it means that it will having a kinetic energy. And if it is having a gas, it means, if it is a gas, it means that the rate would be directly proportional to the gas, then your liquid, then your solid. Okay, so this is basically about my
Okay.
state of a matter. Now the next thing would be my concentration of reaction. So concentration is directly proportional to the rate. Another the same thing. And the fourth one would be the effect of temperature. So this is the most important thing in which the numericals will be asked. So the first one would be the important, I can say that the important temperature, the effect of temperature would be my, basically there is a reaction that we are discussing, the reaction that we are discussing. It is how the temperature is dependent on or I can say that the reaction is dependent on the temperature. So see, if the rate of a reaction is increases, like R is increasing, if a rate of a reaction is increases, it means that key with increase in a temperature, if I increase the temperature, then the rate of a reaction will increases. Okay, if my rate if the
Okay.
temperature is increasing, then the rate of a reaction is increasing. And if it doesn't matter, it would be a endothermic reaction or it would be exothermic reaction, it doesn't matter. I am just discussing about any reaction in which if the temperature is increasing, that means the rate is increasing. And how many times the rate will increase on increasing every 10 degrees Celsius. On every 10-degree rise in temperature, how many times my rate will increase?
Individual.
So it would be 2 to 3 times. This data will be given in the question while you are solving it. Okay, and the formula would be R2 upon R1, K2 upon K1 equals to, yeah, this is the temperature coefficient to the power of delta T upon 10. Okay, this is the formula that you have to remember. Now this is the thing that
Okay.
I'm discussing. This is the fraction of molecules. Here the fraction of molecules are there, and here's the energy. So if you increase the energy, see, this is the energy in which such amount of particles are there, in which the collision, the proper collision is happening. These section of molecules. But when you increase the temperature, the energy increases, and if the energy will increases, means that this fraction of molecules in which the proper collision is happening is increased. And if the fraction of molecules increase, this means that the rate is increased. And in every 10-degree rise in temperature results in 2 to 3 times rise in the rate of a reaction. So this would be my fourth factor. Okay. Now, the fifth factor would be effect of catalyst. Effect of catalyst is my fifth factor. So the catalyst is generally increases the rate of a reaction. And what do you understand by the catalyst? Do you have any idea about catalyst? What is catalyst?
This is right.
So basically, catalysts are those type of I can say that the substances or anything
Mm.
that it'll just increases the rate of a reaction. These are those particles which increases the rate of a temperature. Oh, sorry, rate of a reaction, not temperature. My bad. What is catalyst? Catalyst is generally those particles which increases the rate of a reaction. Okay. It will be there in the reaction, but it'll not never gonna consumed in that reaction. Okay, so it will take part in the reaction completion, but it will never gonna consumed in that reaction. For example, if I take 10 gram of catalyst in any reaction, any chemical reaction, so this 10 gram will remains as the 10 gram before and after the completion of the reaction. It doesn't matter, it just contribute on increasing the rate of a reaction. It will never gonna consumed in that reaction. Understood? Hello, Alicia?
Yeah. Yes.
Understood? Okay, fine. So, how the graph of my energy and my progress of reaction will be changed if the catalyst is introduced in the reaction. So, see again, this is the reactant and this is the product. So, if you see that this is the before addition of the catalyst, without catalyst, this is without the catalyst. This is the reactant, this is the product. But when I put the catalyst into the reaction, then the reaction would be like this. Once again, then the reaction would be like this. See, so if you see that this is the level, this is the energy level for my product EP, and this is the energy level for my reactant. Okay, and this is the difference. This is the energy rate of a reaction's energy. Sorry, this is the reaction energy, and this is also the reactions energy. Okay, so if you see that this is the reaction energy, this is also the reaction energy, but before without the catalyst my activation energy is more. If you see, this is my
Yes.
activation energy. If you see that, just one second. Just one second, just one second. I've done a mistake. Just one second. Now this one would be correct. See, this is the first level. This is the level. This is the energy level of my product, and this is the energy level of my reactant. And the difference between the energy level of my product and the reactant would be my reactions energy. Okay, fine. Now there's two things. This one would be the activation energy before the catalyst is introduced, and this is the activation energy when the catalyst is introduced, after the catalyst is introduced. So this one would be final, this one would be initial. So if you see that this is the activation energy when the catalyst is introduced, and this is the activation energy when the catalyst is not introduced. So there is a gap. There is a gap between the energies. So you can clearly see
Yeah.
that when I introduce my catalyst, then the activation energy is decreased. So basically it decreases the energy barrier. It decreases the energy barrier, or I can say that it decreases
Energy
the
one.
activation energy for the forward reaction or the backward reaction, so that my reaction will complete in a lesser number of time. Okay, understood?
Yeah.
Yeah, so this
Understood.
is all about my catalyst. Now there is
Catalyst.
another thing. This is the graph. So see, like I'm not making two graphs. This one would be. Now see, this is the reactant, this is the product. So if the reaction will start, and this is the flow of a reaction. So there is two peak points in this reaction, and there is one one lower point in this reaction. So these two peak points are known as your transition state, and this one lower point is known as your intermediate. So in a reaction there are two types of things. There are two types of stages. Like if there one would be a transition state, and the other one would be your intermediate. So there's a difference between the transition state and the intermediate. Transition states are those states that states are not never gonna be present for a longer time. For example, if any chemical reaction is taking place, then there is a state in which the bond breaking will taking place, and bond formation will taking place at a same point. Like simultaneously my bond breaking is happening and my bond formation is happening. So those state in which the bond breaking and bond formation is happening simultaneously is my transition state. And intermediate states are those states which are there in between the product and the reactant, and these states are basically a very reactive state, very unstable, very unstable. Okay, so these are what? These are the intermediate state that will be there between the reaction, between like reactant and the product. The state which will comes between the reactant and the product, this one would be your intermediate. And the transition states are those states in which the transition is happening, like the formation of my reactant to the product is happening, in which the bond breaking and bond formation is taking place simultaneously. So this is what, this is the transition state, this is the intermediate state. So if you see that the transition between R to I, there is two transition that is happening. You can see that the first transition between R and I, and the other transition between your I and P, that would be reactant to the intermediate and intermediate to the product. So this, there is two transition state that is happening, okay, in which the bond breaking and bond formation is taking place simultaneously. Understood? And here also the same. So
Yeah.
any chemical reaction, if the intermediate is 1, it means that my transition state would be 2. It is by default. And in any reaction, if my transition state would be 3, then my intermediate would be like 4, then intermediate would be 3. So it means that my intermediate is lesser than, my intermediate is lesser than 1, lesser than the transition state. Understood?
Yeah.
Now,
It's one
now
less
this
than
is
the
the
two.
last topic, that is my Arrhenius equation. So basically, Arrhenius equation is the calculation of the activation energy. We have discussed the activation energy. Now we are going to calculate that activation energy. So Arrhenius is the scientist that proposed the quantitative relation between the rate of a reaction and the temperature. So the rate of a reaction is R and the temperature is T. So basically, Arrhenius is that scientist I can say that that gives the quantitative relationship between your R and T. And what is the relationship? How this relationship will look like? So this is the relationship. This is the relation that will K equals to A e to the power minus EA upon RT. So what is K? So K is my constant, rate constant. We know that already, that this is the
Yeah.
rate constant. This
Yeah.
is Arrhenius constant. A is what? A is my Arrhenius constant. Where is my A? This is the Arrhenius constant. A is my Arrhenius constant. And this is E. E is your natural power, like 2.3. E is the mathematical wala E that we discuss, that we use in the mathematics. So that this is the E, and having a power of EA. EA is my activation energy, and R into T, that would be, R is my universal gas constant. R is what? R is my universal gas constant. T is my temperature. So this is the relation that you have to
Yeah.
remember. Okay, so this is the relation. K equals to A e to the power minus E upon RT. Understood? Now we are going
It
to draw a
should.
graph. We are going to draw a graph. So what? How we'll draw a graph? So see. So the equation would be this. if you see that the relation would be A equals to E, K equals to E to the power of EA upon my RT. This is the relation. What I am going to do is that I am taking log both side. Log both side. Okay. Basically log base E. Log base E. So ln K equals to ln A E to the power of minus EA upon my RT. Understood? Now I'm going to use the log property, that would be this. This is the log property that I'm using here. Okay. Now, so ln E would be 1, and this is the relation ln A minus EA upon my RT. If I convert this into log, then this would be 2.303 log K, 2.303 log A minus EA upon my RT. And if I divide this equation by 2.303, I'll get this. Okay, so this is the equation that I want. This is the equation. So now if I want to draw a graph, so the graph would be like this. This is my what? This is my y, and this, if you see that, this is my intercept C, and this is my minus EA upon my 2.303 R would be my क्या नाम है slope. So the slope is negative, that means the graph would be like this. This is log A, and this one is log A, and this one is the slope of this graph would be minus EA upon my 2.303 R. Understood?
Yes.
So this one would be log K here, and this one would be my T. So this is the same thing that I have discussed here. You can see this is the graph that I have made. This is the equation that I have derived. Okay. Now, what I'm trying to do is that I'm taking two things simultaneously, like here. I'm taking I am going to take two temperatures. The first temperature would be, so the equation of that I have get would be this. This is the equation that I have got. So this one would be at T1 temperature, at T1 temperature. Okay. At T1 temperature. So this one would be T1. Fine. So this one would be at T1 temperature. Great. And the rate constant would be K1. So this one is K1. So this one is, so now this is at K2 temperature, T2 temperature. This reaction, basically I am taking a reaction, the reaction, like this is the reaction, A is going to converting into the product, and I'm taking this, I'm performing this reaction at two temperature, at T1 temperature and T2 temperature. And now after performing this reaction in T1 and T2 temperature, I'm going to compare the relation between my, I'm going to derive a relation between my K1 and T1, K2 and T2. Okay, so see, so K2 is equals to log A minus EA upon my 2.303 RT2. Understood? Understood or not?
What?
Hmm? Is there any doubt? Alicia?
Yeah, no, I understood. Just stop there. Okay.
Any step, if you are facing difficulty at any step, you can ask me, okay?
Okay.
Now what I'm going to do is that this is the first equation, this is the second equation. I'm going to just take the difference between 1 and 2. So I'll get this log K1 minus log K2 equals to this one, and this one is going to be cancelled out with each other, and this one would be my EA upon my 2.303 RT1 minus minus plus EA upon my 2.303 RT2. Now I am going to take common things. So this one would be my Ka upon 2.303 R 1 upon T2 minus 1 upon T1. Fine. So this is the equation, and this is the last formula that you have to learn. This is the last one. This is the last formula. This is the formula that you have learned, and this is another formula that you have to learn. And this is, yeah, that's it. That's it. And this is the last formula that you have to learn. So there are three formulas in this topic. The first formula would be my that we have discussed, the relationship between your K2 K1 R2 R1 is equals to mu delta T upon 10. This is the first formula. The second formula would be my K Arrhenius formula Ka e to the power of minus Ea upon me RT. And the third formula would be this. The third formula would be my
Yes, ma'am.
log K equals to log A minus Ea upon me 2.303 RT. The third and the last one would be 2.303 RT, and the last formula would be my log K1 upon K2 equals to E upon my 2.303 R 1 upon T2 minus 1 upon T1. Okay, so this is the last formula. Understood? So we
Yeah.
have completed this chapter. Now there are some questions that you have to do, and then we are going to moving forward to the next chapter. Okay, just 1 minute.
Okay. Oh, wait. Um,
Your syllabus would be completed till I think January. Okay. Before Feb, your syllabus will be completed. Like second week of the January, second, third. So yeah, this is the, so see, if the K2 is at the denominator side, my T1 would be the temperature that will comes first. If this formula would be like this, like see, if the formula would be like this, like K2 is at the denominator and K1 is at the denominator, the changes that you have done, that you have to do in the formula would be this. The T1 would be the temperature that will comes first, and then after the T2. Understood? So these two formulas are the same, but just we have done some
yeah.
changes, that the K1 would be at the denominator, and the temperature will, then the K1 temperature will come first. So how you can remember this? So K1 is the temperature if it is in denominator, then the T1 is the temperature that will comes first. That's it. This is the way that you have to learn. Now we have completed this.
Yeah.
So this is the first question
Mm.
that you have to solve. Now this is the first question, that's why I'm solving it. The question is the rate of a reaction, the rate constant for the decomposition of hydrocarbon is this. So basically rate constant is K. So the K is given to me, that is 2.418 into 10 to the power of 5 seconds per second, and the temperature is given to me, that would be 546 Kelvin. Okay, so if the energy of activation, that would be EA, is 179.9 kilojoule per mole. Okay, then what will be the value of my pre-exponential factor. So what do you mean by pre-exponential factor? So pre-exponential factor would be a. So what is the value of a? This is the question that is asked to me. So the formula that I am having is my k is equals to a e to the power of minus e upon my rt. This is the formula that I am having.
Yes.
Yeah, it is. This is the formula.
Mm, yes. No.
Like k is given to me, and e I know that it is the exponential factor, and this is what, this is the power. Activation energy is also given to me, temperature is given to me, r I know that it is the constant, that's why I know the r
Yeah,
value of
you
r.
also.
I have to find just a pre-exponential factor, this factor that I have to find. So a is the one that is asked to me. So what I'll do, I'll just take the log both sides, so I'll get this. After simplifying this, I'll get the formula, this one. The formula would be log a minus ea upon me 2.303 r and t. This is the formula. Okay. Now just put the values. Log 2.418 into 10 to the power of 5 and equals to log a that you have to find minus ea. So the value of ea would be 79.9 into 10 to the power of 3 divided by 2.303, multiply into, then everything is in the SI unit. Then what is the SI unit of my your R? Can you tell me what is the SI unit of R? Hmm? Can you tell me what is the SI unit
Gas.
of R? There are many there are many units of R. You have to tell me the SI unit. Hmm?
I don't.
What? I'm not able to hear you properly.
Yeah, I don't know.
Okay, okay. So you have to take. Okay, there are many SI units of R. I'm going to tell you one by one. Okay, just see 1 minute. So basically, see. mm, So see, these are the units of R. So per mole per Kelvin, joule per mole per Kelvin is my SI unit of R, gas constant. Okay. Now the other unit, if the question is asked in liter at ATM per mole per Kelvin, then the unit that you have to take is this. And if the question asks you in bar mole per mole per Kelvin, then the value of R you have to take is this. And when the question is in calories, then you have to take the value of R would be this. So these are the values. So the question is in SI unit. So 8.3. I can take the SI unit. You can see that 8.3 14 if you want. So I can write 14. This is the SI unit, and the temperature would be 546. So I have put in all the values that is given to me. Then I have to solve for log A. Now just solve it, like log 2.418. You have to solve the values of you have to solve this question. Okay, just solve it and then tell me what is the answer of log A. Just tell me the answer of log A. Okay.
So could you do the calculation?
Hmm.
Could you do the calculation?
Okay, see. So first of all, log A. The log wala part that you have to first of all learn that how to take anti-logs and how to solve for logs. So that you have to done by your own self in your home, or you can ask from your teacher, maths teacher that will help you. But I'll help you how to solve it. So 19.9 into 10 to the power of 3 divided by 2.303 multiplied by 8.314 multiplied by 546. Okay. Now see, I am just substituting log values of log. This is minus, I think. Yeah, this is minus. Minus, correct. So log 2.418 plus log 10 to the power of minus 5 plus this thing. Let take this thing as x. So x. Okay, now log 2 point you can solve this log by using your calculator if you want, or if you want to learn how to solve the value of log or to take the anti-logs, then I can teach you the log wala part in the next class. But in this class we have to move forward because we have to start the next chapter as well. So if you want, you can just tell me the answer in this form as well. Okay, just put the values and just get this expression. If you are able to get this expression, I will understand that you have solved it. And in the next class, I'll tell you how to solve the values of log, because it will take time. Like it will take one lecture to tell you how to solve the logs and the anti-logs, how to take logs and the anti-log.
Yeah.
So I'll explain you in the next class if you want, or if you can do that key in your home. You can this is the homework that you have to learn how to solve the logs. Okay, this is the homework. I will explain you in this next class as well, but you have to do it by your own self as well. Understood? Hello, Alicia.
Yeah, understood.
Okay, fine. Now the next question would be this: to solve this. Okay, I'll solve you for you. I'll solve it for you. Just one second. I'll explain how to solve. See how to approach a question. How I am approaching, you have to observe me. So first thing is the rate constant of a reaction is given to me this and this. So there is two rate constant. The K1 would be 0.02 and the K2 would be my 0.07. Okay. Now the temperatures are given. T1 temperature is given to me, that would be 500 Kelvin, and the T2 temperature is given to me, that is 700 Kelvin. And the question asks me about that we calculate the value of E and A. So first of all, I have to calculate the value of EA and A. Okay. So it's easy how to solve it. Just one second. Okay. I'll tell you how to solve it. See. So I'll help you. So the formula would be log K1 upon K2 equals to your K1 upon K2, then EA upon 2.303 R 1 upon T2 minus 1 upon T1. Okay. Now put the values in this formula and solve for your, first of all, EA. Okay. Solve it for your EA. Okay. Solve it. When you're done, you can tell me. Okay.
thing.
Can I solve?
Yeah.
Okay, see. So put the values of k like 0.02 divided by 0.07 and EA that you have to find and 3 point this and the value of R would be my 8.314 and the value of T2 would be 700 minus 500. Okay, so the two zeros are cancelled out and log 2 minus log 7 and this would be EA upon 2.303 8.314. So if you solve this, so 500 minus 700 divided by 3500 and this one would be your the value of log 2 would be your 0.31301 and the value of log 7, see log 7 I can write it as log 3 uh, I can write this log 7 as my log 3 plus log 4. Okay. And this thing I can write it as just one second. Okay. So logs you have to learn the value of log 7. So there are some values of logs like I'll tell you log 1, log 2, log 3, log 4, log 5, log 6, log 7, log 8, log 9, log 10. So the value of log 10 would be your 1 and the value of log 1 would be your 0. Okay. The value of log 1 would be 0 and the value of log 10 would be 1. Okay. Now this one is your point 301. The value of log 2 would be 0.301 and then the value of log 3 that like you have to learn the odd values like this log zero point 0.3 and log 5 log 7 and the others will be easily going to be cancelled out easily going to be calculated. Okay, so you have to learn the values of log 2, log 3,
Yeah.
log 5, log 7. Now I'll tell you the values of log. Just once again, I'm just calculating it. Just it skipped from my mind. So log 3 would be just once again. So 3. So log 3 would be your 0.077. So this one would be your 0.477. Just once again. And the value of log 5. The value of log 5 would be my 0.69.98, sorry, 0.698 and then the value of log 7, then the value of log 7. Log 7 would be my 0.845, 0.845. Understood? So these are the value of this. And then value of
Yeah.
log 4 would be your 2 ki power 2. And the 2 will be comes up in the multiplication. So this is the value of log 4. So you know the value of log 2. Then you have to just multiply it by 2. So that you will get the value of log 4. Understood? Now for log 6, again the same thing. 2
Yeah.
multiplied by 3. So log 2 plus log 3. Okay, you know the value of log 2, you know the value of log 3. So you already know the value of log 6. So again, the log 8. So log 8 would be like this, log to the power of 3. So 3 to the power of 3. So 3 is multiplied with the value of log 2. So you'll get the value of log 8. Now the log 9 would be log 3 to the power of 2. So 2 is going to be multiplied with log 3. So you'll get the value of log 9. Understood? So now you have to just learn the value of log 2, log 5, log 7. That's it. Okay. How many values that you have to learn?
Yeah. Log
So
2, 3,
1,
5, 7.
2, 3, 4, 5. Oh, sorry, 4. Only 4. Like 4. So other values
Yeah.
you can solve it by your own. Okay, so this is the thing. Now the value of log 7 would be my 0.845 and EA that you have to calculate. And if you
Yeah.
multiply this 2.303, 2.303, if I multiply this with my like 8, you get 8.314. So I'll get 19.14. Okay. Now this one would be my 0 and 0, 0, 0, 0, 0 going to be cancelled out with each other. This one would be -2 divided by 35. Okay. Now if you calculate this thing, that would be 0.301 minus 0.845. So you'll get minus 0.544, and this one would be your this one. So you can now I will solve. Yeah, good. No, it's fine. So if I solve it, so I'll get this 0.544, and EA divided by 19.14 and -2 upon my 35. Okay, so minus and minus going to be cancelled out with each other, and the value of EA would be 0.544 multiplied by 19.14 multiplied by 35 divided by 2. So after calculating all the stuffs like minus like multiply by 19.14 multiply by 35. Okay, and you'll get divided by 2. You'll get the answer as 18.2. 80, the answer would be 182.2. The answer would be 182.2 joules. This is the SI unit. Fine. This is in joules.
Yeah, fine. Fine.
Okay. So basically, the tough part would be in the calculation, if you see that. So you
Calculation.
have to learn the
Yeah.
value log, and then you have to just do multiplication division, and then just get the value of EA. When you get the value of EA, then after you have to just do one thing, like just 1 minute. Then you have to just do one thing, which would then for solving A, you have to apply the formula of log K equals to log A minus E A upon my 2.303 R T, this formula. Okay, so just put the value of K, just the what K, like we have two K1 and K2, and two temperatures, T1 and T2. So which K and which K1, which value of constant that you have to take, like, and which temperature that you have to take. So any temperature, like for example, if you want to solve for T1 temperature, then you have to take K1, and if you want to solve for K2, then you can take T2, because this is the constant thing. Then this would be constant for any K1, K2. So if you want to solve from K1, you can do it. If you want to solve from K2, you can do it. But if you take K1, then you have to take T1. If you want to take, if you take T2, then K2, then you have to take T2. Okay.
T2.
So let's solve for K1. So the K1 would be 0.02. Okay. So 0.02 equals to log A minus EA that we have solved would be my 82.2, 182.2 divided by 2.303 multiplied by R would be 8.314, and temperature would be 500. Temperature would be 500. That's it. So this thing I can write it as log 2 minus log 10 to the power 2. Okay, how I have written this? So see, log 2 divided by 100, and I can write it as log 2 minus log 100, and I can write this 100 as t to the power of 2. Okay, so the value of log 2 is 0.301 minus 2 multiplied by 1. and log A minus may now solve this. So the 2.303 multiplied by 8.314 multiplied by 500. So the value would be this. Okay. So the value would be this once again. So this one is point, this once again. So 2.303 multiplied by 8.314 multiplied by 500. So you'll get this. So 82.2 divided by 9573.57. Okay. Now let's solve this. So 2 minus 0.301. You'll get 1 minus 1.699 plus 82.2 divided by 9573.57 log A. So log A is equals to this. So this thing I have to solve, no? So 182.2 divided by this one would be 9,573.57. I'll get the answer as 0.01. So 0.0190. Okay, so 090 minus 1.699. So minus it with 1.699. So I'll get my answer as this minus 1.67. So this is the answer that I'll get. The value of log A is my minus 1.67. If you want, then you have to take here the anti-log. So the anti-log wala part I will explain you tomorrow in the next class. Basically. Okay. So the final answer would be this at your level that you are present.
Yeah.
Okay.
Okay.
So this is the answer that we'll get. So basically what we have done, first of all, we have solved for EA. Then after we'll use this formula and just put the values and just simplify. Okay.
Yes.
In the examination, the calculation would be far easier than this. I think you do not need any calculator or anything. Why? Because the value of like this, the log A minus 1.67 is given to you in the exam. The values of the logs and the values, the unpopular logs, not these logs. Most probably the examiner will give you the value of these logs as well, but the unpopular logs that you do not know the values, it'll given in the exam, and the anti logs that you have to take in the exam is also given in the exam. So you do not need to worry about the calculations. Why? Because it is simple. But you have to know that the different properties of the log, where you have to
Steps.
apply the properties of the log and all. Okay, so you do not need to worry about the log. You have to worry
Okay.
about this section, like till this section, how I'll get this expression. If you're not able to get this expression, then there is a thing to consult.
Got
Understood? So this is all
Yeah.
about chapter. There is last question that is left. If you want, you can solve it. Okay, solve it. Solve this question. This is the last question, and then we will move forward to the next chapter that will be my electrochemistry. Done.
No, is it which formula is it the second formula?
You have to think by your own self. Like, what are the given part that is given
Yeah.
given to you, and what is the thing that is asked by the question to solve. So just use your mind.
Third one. Is it log k is equal to log a minus?
Okay, see, I'm solving it. Just match your answer. Okay, so rate of a reaction doubles for an increase in
Mm.
10 Kelvin, okay, in absolute temperature from this. Calculate EA. So basically what is given to me is that key if I increase the temperature from 298 Kelvin to 1308 Kelvin, so once again 298 298 Kelvin to 308 Kelvin, then
Okay.
rate, then the rate would be this. Then the rate will becomes double. Then the rate doubles. This is the given part. Okay. So can you tell
Yes.
me what is the formula that is associated with it? If I want to find EA, then how many formulas that I have? So the first formula that I have,
The
I'm writing
fourth
all
one.
the formulas. Okay. K is equals to A e to the power of minus EA upon my RT. The second formula would be log K log A, and this is the same formula. Just I have done some simplification, minus EA upon 2.303 RT. The third formula would be my like if the K is basically delta U, or I can write it as U. I can write it as U to the power of delta T upon what 10. This is okay. So these are the uh, formulas that I'm having. So how can I find this? What are the required things that is given to me, and what I have to apply? You have to think. Just use your mind for 1 minute, and then tell me. Just think about it. Yeah, 30 seconds. Okay.
Is it
Let me
third
tell you.
one?
Hmm.
The third one? The third one.
The third one. Why?
Because
Why?
change in temperature.
Huh?
Change in temperature.
Okay, change in temperature is fine. Okay, there is another formula like I haven't written, like log K1 K2 equals to EA upon 2.303
Yes.
1 upon T2 minus 1 upon T1. So we have four formulas. So you are telling me the third formula, no? Is it?
Or the fourth one. Fourth
Why?
one,
The
yes.
fourth one, why? And what is the value of K1, K2,
Because
T1,
in the
T2?
question,
If it is 4, then what is the value of K1, K2, T1, T2? Tell me.
uh, T2 is 308, T1 is
Fine.
298.
Okay, okay. So T1, T2 is, I know. So K1, K2, what about K1, K2?
Uh,
It is also given to me. See, at this
yeah,
point, the rate would be R. And at this point, the rate
yes.
would be, at this
Yeah,
temperature, the
2
rate would be 2R. So basically,
2
I
hour,
know
yeah.
that my R is directly proportional to K. So if I increase the temperature, my K will increase, my R will increase. So it's very simple
Yes.
that my value of K would be K1 at the initial point and 2K1 at the final, like after increasing the temperature. So this one would be T1, this one would be T2 at T1 temperature, T2 temperature. So now just put the values. So K1 upon my 2K1. equals to EA upon 2.303 1 upon T2. Okay, so T2. So that means 308 minus 1 upon that would be your 298. Okay. Now this solve for R is left behind. So R. Now K1, K2 cancel out with each other. Log 1 minus log 2, and this one would be 0, and this one would be minus 0.301. K EA, I have to find it upon 2.303 R upon me. Now this thing you have to solve this. Okay, how can I solve? How you'll solve it?
LCM.
So just do
Cross
simple
multiply.
like division 1 upon
Cross multiply.
308. I'll get 3 point. I'll get what 10 to the power minus 3. Okay, so I'll get 0 0.0 like just 1 second. Just 1 second. Okay, so it would be 1 upon 308. Okay, so this one would be 0.0 0.0 0.032. Okay, so this one would be 0.032. One more zero is there. Just 1 second. 0.032 minus 1 upon 298. This one would be 0.00335. 0.00335. Okay, so this is it, and solve it. Now you have to multiply this with 2.303 R and divide this with this wala factor. This one would be your, just 1 second. If you subtract it with 0.0032, you'll get 0 0.0032 minus 0.00335. You'll get minus 0.3. You'll get minus 0.00015, and this point and this point is cancelled out with each other, and the value of EA would be 0.301. So you'll get the expression this expression. I'm just doing some calculations for part. 3.00 R divided by 0.00015. Okay, so this is the solution. Just solve it by just multiplying. I'm not doing it because we'll lose some time. Okay, in this. So it's just calculation all part. So I understood how to solve the questions. Okay, so just do not worry about the
Yes.
calculations. You can easily solve the calculations because examiner will give you the easier calculations. You can easily solve it. Okay,
Okay. Okay.
understood. Hmm.
Could you repeat?
If you have any doubt, you can ask me because the chapter is completed in any section.
Now the calculation part.
So
What's
basically the calculation part is tough. I know that. You have to first of all, what are the things that you have to do for the calculation? The first thing is that you have some knowledge
law?
about the logs, like how to solve the logs. If you
Yeah.
are not able to, if you do not aware of the properties of the log, and if you do not learn some values of the log, you are not able to solve it. The first thing. And the other thing is that if you are able to solve some simple calculations based on the log, then it will be very easy because such type of calculations are basically avoided in the examinations because the examination is it is bounded of some time. So if the calculations are very tough, then most of the time will be, uh, you know, most of the time will be on the calculations, and the exam will be very lengthy. So for that, the calculation, you do not need to worry about the calculation. If you are able to solve the question till this part, then the examiner will give you full marks. Just half marks will be deducted because of the calculation, last calculation. Okay, so for the half marks, do not lose the concept. Okay, it's just the half marks. Okay, do not worry about the calculation,
Okay.
just worry about the concept. If you know the concept, that any doubt?
Oh, no, no. Sure.
Okay. Okay. Basically, your video is lagging. I think there is some connection issue from your side.
Yeah, the network is low here.
Okay. Okay, so let's move on to the next chapter. I'll give you the intro of that chapter. That would be my electrochemistry in this class, and then the next class we'll complete one or two sections of that chapter. So the chapter would be just one
Okay.
minute, just 1 second. Okay. Okay. I'm just making another PPT file. So just wait 1 minute. So just 1 minute. Okay. So is the screen is visible to you? Like black slide.
Yeah, it's visible.
So the next chapter would be my electrochemistry, and this is the last chapter of the physical chemistry of the class 12. Physical electrochemistry. Electro. So just 1 minute. So basically, this is the chapter which is based on the like electrochemical reactions. What do you mean by the electrochemical reactions, and what is electrochemistry? So let's segregate this word, this term, electro. Electro is basically is for the flow of charges. Electro is for the flow of charges. And chemistry, you know that chemistry is basically your a branch of science which will deal with. Okay. Hello, Alicia.
Hello.
Hello, Alicia. You're not audible.
Hello.
Am I audible?
Yeah, now you're audible.
Okay. See. So basically, electro is for the flow of charges. What? Flow of charges. And chemistry, you know that. Chemistry is the branch of science, or you can say that it is the branch of science which will deal with the atoms, molecules, compounds, and their nature, how they exist in the nature,
Yes.
and how they react with the nature, what are the changes that will happening uh, if they react, or etc etc. So basically we are going to deal with the flow of electrons, and the chemistry which is related to the flow of electron is your flow of electron, or I can say that flow of charges, not electron, flow of charges. uh, More specific would be flow of charges. So it is the electrochemistry. So in the electrochemistry, there is a term which is known as your electrolytes. Electrolytes. So what is electrolyte? So basically, electrolytes are those substances, or the, I can say that, particles that will dissociate while going in the solution. It will segregate, and after the segregation, then they will conduct electricity. And basically, electrolytes are generally those which are
Yeah.
having some charges on it. For example, like I'll give you some example. Just wait. Okay, so just 1 minute. Yes. See, so if you see here, conductor are those which will conduct the charges, that will flow the electricity, that will flow, that will allow the flow of the
That's
current.
it.
So basically, conductors are two types. The metallic conductors. Metallic conductors are those that carries the current, which are known as your conductors.
Mm.
Hello.
Yeah, yeah, I'm back.
Okay. See, basically, metallic conductors are those conductors which are having a carrier of currents, and the carrier of currents are the electrons. We know that electrons are those which will carry the current. So basically, these are the what, metallic conductors. And electrolytic conductors. There is two types of conductor. If one would be metallic and the other one would be electrolytic conductor. Their carriers would be the ions. So basically, the holistic difference between the conductors of the between the conductor of the metallic and the electrolytic would be based on the carriers, that how the current is flowing in it. So the current is flowing if through the electrons, then it would be the metallic conductor. Okay, like for example, iron, copper, etc etc. See, now if I'm talking about the electrolytic conductors, then the carrier would be my ions. Okay, fine. Now there are two types of electrolytes. The one would be my weak electrolyte, and the other one would be my strong electrolyte. So the strong electrolyte are those electrolytes that will ionizes 100%. Like for example,
100%.
HCl. If I dissolve this HCl in a water, it will 100%ly ionize. Then and I have explained you this thing in the first chapter of this, which is the solution, in which when we are discussing about the Van't factor. In that, I'll explain you that those substances which will dissociate in dissolving in a water, dissolving in its likely solution, then the number of solute particles will become more than its initial it was there at the initial point. So if the number of solute particles is increasing, that means that my number of solid is if my number of solid is increasing, that means my colligative property will change, that I have explained you in the first chapter. But in this
Yes.
chapter, the again the same thing, that would be my strong electrolyte, in which it will in which the 100% of the ionization is happening. Okay. Now the other one would be my weak electrolyte, and this weak electrolyte is basically partially ionization is occurring, A and B, which will going in a partial ionization, A plus B. And what is partial ionization? Partial ionization is basically the ionization in which some amount of the reactant is going to be ionized, not 100%. It will be in some amount.
So,
Understood? The amount is very lesser. Okay,
yes.
so the examples of the strong electrolytes are basically the strong acids like HCl, HNO3, H2SO4, etc., and the strong bases like NaOH or KOH, etc., and the salts would be like NaCl, K2SO4, etc., etc. So these are the example of the strong electrolyte. And if I talk about the weak electrolyte, then the weak electrolyte are those electrolytes which will going to be partially ionized, and the example
Partially
would be
honest.
like this carboxylic acid, alkyl carboxylic acid, or your
Yes.
HCN, H2S. And if you take the bases, then it will be NH4OH, and if you take the salt, that would be your NH4CN. So these are the example of the partially electrolytes lights. Okay, so why we are discussing about these electrolytes? Because these are the ions, or these are the particles, or these are the substances that are going to conduct an electricity, and that will bring out the change in the chemical reaction,
Reaction.
that will basically helps our reactant to convert into the product. Understood?
Yeah, understood.
So this is about my basic intro of the electrochemistry. Now, the first section would be my conduction section. We are going to discuss about the conduction section in the electrochemistry. So the in the conduction section, there is one thing that would be my Ohm's law.
Hmm.
And what is Ohm's law? Can you tell me? It is basically, if I talk about in a very general term, that would be I is exactly
Charge by.
B is exactly proportional to I. In a very general term, I know that it is
Yeah.
not completely correct.
Yes.
Okay, it is not completely correct. But in general term, if I use the knowledge of class 10th, then it is basically V is directly proportional to I. So in which if I increase the potential difference across the conductor, then across the electrolyte, I can say that, then the current is also going to be increased up. And if I remove the proportionality sign, there is a constant that will pops up, that would be R. And this is the resistance that will offer the opposition in the flow of the charges, or I can say that in the flow of the ions. So basically what is going to happen here is that there is an electrolyte that is there, and which when the electricity is passed through it, there is some chemical changes that will occur. Okay, so this is, and there is a process which is known as the electroplating, and etc., and etc. So these are the
Yeah.
processes that are basically associated with the electrochemistry wala section. Understood? So now the first
Yes.
thing that I have told you is the Ohm's law. Okay. And then the Ohm's law is basically, from the Ohm's law I can relate, I can explain all the properties of the conduction that is related to the electrolytes. So the Ohm's law is the definition of the Ohm's law. We all know that across the conductor, the flow of I can say that the potential difference, according to it, the current flowing through the conductor, any conductor, is directly proportional to the potential difference which is across the conductor. So V is directly proportional to R. It is not completely correct, or I can say that it is not the correct definition, because there is some here and then differences that will be more discussed in the physics wala section. But till now, if we use the knowledge of class 10, this would be the correct thing. Okay, now then the next thing would be
Yeah.
conductance. So basically, conductance is what? Conductance is the ease in the flow of the current. Ease in the flow is what do you understand by the ease in the flow? It means that the the, the,
Pass.
the proportionality of how a electrolyte is allowing the charges to flow through it. It is basically the allowance, or I can say that the uh, ease. You know that what is ease, है ना? आसानी, कितनी आसानी से वो पास कर
Yeah,
जाए.
heat.
Yes.
Yeah.
Yes, so this is the conductance, and it is represented as G, and it is reciprocal of R. I know that.